Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're looking at Dalton's Law again. And when we look at Dalton's Law, we're going to take it up a level and explain how we got certain values. So, quick review, Dalton's Law, that's his picture there. Dalton's Law is defined as the total pressure in a closed system is equal to the sum of the partial pressures. And the basic of the equation would be that P total is equal to all the sums of all the partial pressures. Now, quick review, and here's the water vapor chart right here. So if we want to find, and I have the value there, that's out of the chem book that I was using. Determine the pressure of chlorine gas collected over water at 26 degrees Celsius. If the barometric pressure is 756.99 torr, we go over here and we look at 26, we get 25.2 millimeters of mercury. So using Dalton's equation, we get P total is equal to P sub A plus P sub B, whereas chlorine and water, the total pressure is going to be the barometric pressure. That's what causes the water inside of it to move out. When the barometric pressure, the pressure inside of is equal to pressure outside, it pushes the water out. So therefore, 21.21, I think that the other book had a little more values to it. All right, all we have to do here is subtract then. So the P of chlorine then is 731.78 torr. That's it. All right, now let's take the ideal gas equation. If we take the ideal gas equation and move V to the other side, we get P is equal to nRT over V. Now, using Dalton's law, we can say that P of A plus P of B plus P of C plus blah, blah, how many we have. So we can input those. Now, if you look here, we see that RT over V, RT over V, RT over V. Those are exactly the same values. So we can move all the n's out. And when we do that, we get the equation P total is equal to N total, all the total number of moles, times RT over V. So let's do a problem here. Let's identify the total pressure in a system with a temperature of 51.44 degrees Celsius. The system contains 55.08 grams of oxygen, 44.01 grams of nitrogen, and 6.91 grams of argon in a 4.899 liter container. This is going to be very high pressure, calculated in kPa's. All right, so we start with oxygen, and then we have nitrogen and argon for the problem as well. Put all those over one. Now, in order to find the N total, we're going to have to find the moles of each. So oxygen is 16, but it's diatomic, so it's 32 grams for oxygen. Nitrogen is also diatomic, 14 times 2, 28, and argon's 40. We multiply through, we get 1.721. There's 4 sig figs and 55.08 for oxygen. For nitrogen, it's 1.572. Well, I did fix it, so N2, not O2. That was my mistake. Let me fix that there. I'll fix it before we go over. And then argon there as well. When now we add them up, the total N here is 3.466 moles. All right, now plug in the equation. P total is equal to N total RT over V. Our N total, we just said, was 3.466 moles. R, because we're doing kilopascals, is going to be 8.31 liters kilopascals per mole Kelvin. The temperature here is 51.44 degrees Celsius, but we need that in Kelvin. Add 273, so we get 324.44 Kelvin. And our volume is going to go on the bottom, 4.899 liters. Our Kelvins cross out, moles cross out, liters cross out. Left with kilopascals right there in the middle, like it is. So we take 3.466 times 8.31 times 324.44 equal, divide by 4.899 equal 4 sig figs and 3.466, infinite in the constant. 324.44 is 5 sig figs, 4.899 is 4 sig figs, 4 infinite 5, 4, least number is 4. Answer is 1,907. It's a high pressure, and that's our answer. Now, we can take and put our P1 over P2. When we do that, if we apply the equation we just said, we can see we have N1 over n sub 1 RT over V over N total RT over V. And doing a little quick math, you can see those values are exactly the same, so we can cross them out. So N1 over N total, hopefully you remember from last section, that's mole fraction. And when we do that, we get the equation then, because movement P1 is equal to X1, R1, X1, P1, and hopefully you remember that's Raoult's law. All right, so let's take and do a problem. Determine the partial pressure of nitrogen in the last problem. So we have to go back and look. Let's go back up here. Nitrogen's right here, 1.572 moles. The total pressure is 3.466 moles. And the total pressure, we said, the total moles is 3.466 moles. Total pressure is 1,907. So let's go back and identify those values. There we go. So we take Raoult's law, P1 is equal to X1 over P2, P total, and we're doing it for nitrogen here. We're trying to find it for nitrogen. I don't want to put N2 down there because it's not going to work. So X1 is going to be the 1.572 over 3.466. Now I can multiply this through, but and technically if we do sig figs, then we'd have to round and we generate. So let's just keep it to the end, so that way we limit our mistakes and errors. And then our P total there. So we take 1.572 divided by 3.466 equal times 1907. 4 sig figs, 4 sig figs, 4 sig figs. Answer is 864.9 kilopascals, and that's our answer. All right, we're done. Hopefully not too bad. Take care. God bless.